Okay, so on to the rest of the 10.2 notes. I got one word problem here. So we need to make sure that we've got that first equation set, and then we'll worry about what the equation is telling us as far as kind of um, how the variable terms are being related to each other and how this equation is going to be made so that we can solve it. So it starts off by telling us Mike is designing a shed. He wants the building to be in the shape of a rectangular solid with the same width and length and a height that is 2 feet shorter than the width. Okay? So one thing that's important to get out of this here, actually let's draw this a little bit easier here. So the height and the width, length and the width are going to be the same, but that height is going to be a little bit less. Okay, so the length and the width, the same. Okay, so this is the rough shape of that shed before probably a roof is being put on. So we've got the length, we've got the width, and we've got the height. Okay, now they want us to write and solve an equation to represent the volume of the shed, and then in terms of width is going to be a key part of what's going to help us out here. So first of all, the volume of something, we need to know that before we can use what the rest of this equation is giving us to make this doable. So it's the width times the length times the height. We multiply all three of those things when we're finding the volume of something. Now, one piece of information they gave us is that we have the same width and length. Now, they want it in terms of W, okay? So we want everything to turn into some form of W. So the width is just W, okay? Now, how can we relate the length to W? Well, they tell you that the length is the same as the width. So length and width are the same exact thing. So we can just replace that L with a W. So we've got the volume right now equaling width times another width, because that L is equal to that. And then the height is 2 feet shorter than the width. So the height is going to be the width minus 2. So if the width was 10, the height would be 8. Right? It's 2 shorter than whatever the width is. So it's both these W's times W minus 2. We can replace that H with W minus 2 because they wanted it all in terms of W. So they want you to turn all of those variables into some relation of W. So now that we've got that done, we're going to be multiplying everything together. So that volume is going to equal, well, the width times the width, first of all, is W squared. And then we're going to multiply that by W minus 2. So when we go ahead and multiply that W squared by both of those pieces, we're distributing that W squared to multiply by both those pieces in the binomial. So W squared times W is going to be W to the third. Okay, W squared times W, it's 2 W's times 1 more, so there's 3 W's there. And then W squared times a negative 2 is just negative 2W, negative 2W squared. Okay, so we can't combine anything else. There's no like terms to combine. There's nothing else to multiply. So in terms of the width, that's your volume. That's going to be your volume in terms of your variable W. Okay, so then if we knew the width, we would be able to find out the volume. If they asked you, find the volume if the width is 8 feet. Okay, if we had to do that, we would be plugging 8 in everywhere that there's a W. We would say volume equals 8 cubed minus 2 times 8 squared. Erase that real quick. Okay, 2 times 8 squared. So 8 cubed would end up being 512. And then 8 squared is 64. 512 minus whatever 64 times 2 is. 64 times 2 is 128. So the volume would be 512 minus 128, which is going to end up being 384. So that would be 384 cubic feet because we're talking about volume. So your answer for the question asked was right here, and that would be useful in a situation where you would know the width or even the length. If the length equaled 8 feet, because the length is the same as the W, we could then plug that in for W. So they didn't ask you to go that far with it, but that's an example of a situation where you would take that one step further and actually solve for a specific measurement. So now the way that this is going to end today, we're going to take this multiplying monomials and polynomials, and we're going to apply it to solving equations. So this is very similar to something you've done before. We're just adding an extra step in there. So when you're solving this first equation, the very first thing we need to do is distribute that -5. You can't combine like terms. You can't move values across that equal sign. You can't do any actual solving steps until all the grouping is taken care of. And all the grouping is going to need to be taken care of using the distributive property. So 3p is staying on the left hand of the equation here. -5 times p is going to give us -5p, and -5 times 8 is going to give us -40. Once you're here, we need to get all the variable terms to one side and leave the constant terms on the other. I would just move that -5p over. I would add 5p to both sides so it cancels on the right. Remember, whatever you do to one side, you have to do to the other. I'd be left with 8p equaling -40. And the last step there to get the variable all by itself is to divide whatever is in front and multiplying. So I've got p equaling -5, and that example would be done there. Okay? For the next one, I've got a couple situations where I need to distribute first. My first distributive step is going to be the -2 times both of those pieces in p plus 3. So I have -16p here on the left. -2 times p is going to be -2p. And -2 times 3 is going to be -6. Now I have to go ahead and distribute that second grouping so that I can have everything out in the open. I can combine like terms and move things around. So I have 3 times 6p, which is going to be a positive 18p, and 3 times -30, which will be -90. So now I have to go ahead and combine my like terms first. Okay, remember, I don't want to move anything over across that equal sign until everything is combined. So my like terms, I've got a -2p and a positive 18p, and then I've got a -6 and a -90. I'm just using different shapes here. So the left side has not been touched yet. It's still going to be -16p. That -2p plus 18p, well, just what's -2 plus 18? That's going to be 16, and that's my variable p. I have 16p, and then -6 minus 90 is going to be -96. Now I have only one type of each term on each side of the equation. Now I can go ahead and move things over. I'm going to want to move this 16p over to the left-hand side to be with the other variable term. So I have variables on one side, constants on the other. So in order to move a positive 16p over, I'm going to subtract so it cancels. So I end up with -16p minus another 16p, which will be -32p. And then it's equal to whatever's left over, which ends up being this -96. And the last step to solving, remember, I need to divide by that number in front of p, and then I will end up with my final term. So I'll divide everything here by -32. Whatever I do to one side, I have to do to the other. And these look like, excuse me, these look like messy numbers. It actually ends up pretty nice. -96 minus a -32. Well, first of all, a negative divided by a negative is a positive. 96 divided by 32 is just 3. So you end up with 3 as a solution to that big ugly equation that we started with. Okay? One more, there actually is going to be distributive steps in every piece of this. So -2q times 4q is going to be -8. Now q times q is going to be q squared, -8q squared. Be careful with that first one. Then -2q minus, or times a -9, excuse me. -2 times -9 is a positive 18, and then there's just that one q involved. Okay? Then I've got q times -8q, that's going to be -8q squared. Q times 15 is just 15q. And then the last set of distributive steps I need to take, -3 times -4q is going to be a positive 12q. and negative 3 times negative 6 will be positive 18, and negative times a negative is a positive. Now I want to go ahead and combine my like terms first. Okay, combine your like terms first. Like terms. I have no like terms on the left-hand side. On the right-hand side, I have a few, just one pair of them. I have 15q and I have a positive 12q. So that negative 8q squared is going to stay the same. So on the left-hand side, negative 8q squared plus 18q hasn't been changed at all. There's no like terms on that left-hand side. We're only combining what's the same on each individual side right now. On the right-hand side, that negative 8q squared also is unchanged. The 15q plus the 12q is going to give me a positive 27q, and then that positive 18 is also hanging out. So what's going to happen next? Well, we've got to get these variables on the same side as each other. So the first thing I'm going to do is I'm going to take this negative 8q squared. I want to get it over to the left-hand side. In order to cancel that out, I'm going to bring in a positive 8q squared, so it cancels out on that right side. So I add it to the other side as well. Well, what happens when we add 8q squared to the left-hand side? It's another situation with negative 8 plus 8. That's also going to cancel. So all my q squared terms are gone. So now I've got an 18q on the left-hand side. On the right-hand side, I have a 27q plus 18. So now we're to a situation where, again, I just have to get all the variable terms to the left-hand side. I want to move that 27q over to be on an opposite side of that 18. So I'm going to subtract by 27q so that it cancels on the right-hand side. Subtract 27q from the left. So 18 minus 27 is going to give me a positive, it's going to give me a negative 9q. And then that's equal to the only thing left on the right-hand side at this point, which is 18. And my final step to go finish this problem, I divide by the negative 9 that is in front of q, and I end up with q all by itself equal to a negative 2. Positive 18 divided by negative 9 will give me negative 2. So that one had 3 distributive steps in it. I combine my like terms. I move things over by canceling so that the like terms can get on the same side of the equal sign. I get down to having variables on the one side, constant on the other, and then that last step is to divide whatever's in front. And I end up with a nice whole number of negative 2.